Okay. Cedric, so I think we are live.
Great. Hi, everyone.
Yeah, so hello everyone. If you can see us, if you hear us, please write something to the YouTube chat so we can start. All good here. Hi all. So many people today, that's amazing. Perfect, perfect. We can hear you, we can see you. So that's great. Today is a Monday, and many people say what Monday is a bad day. Monday after like a weekend, you have to go to work, you have to do something, and maybe you prefer to stay at home. Well, we all stay at home mostly during this year 2020, very special year indeed.
Indeed, that's very special.
But we want to break this tradition. We want to change that. We want Monday to be your most favorite day of the week. How come? Because of the data stacks Monday learning. That was the idea of this gentleman from Paris sitting left to me.
Yes.
Yeah.
Hi, guys.
Yeah. So, Cedric, would you say a couple of words about the data stacks Monday learning?
Yes, so this is a new initiative we are launching today. We are starting with Docker. It's back to basis, cover a topic that will talk to everyone, just to get everybody excited about what we want you to learn and make the DataStax family even bigger.
Yeah, exactly. So, as you know, most of our workshops on Wednesday and Thursday are connected to the Apache Cassandra and clouds and cloud natives, but we also want to speak about the more general topics, like about the clean code, code quality, or I don't know, maybe continuous integration and delivery. And specifically for the next few weeks, we are going to speak about Docker. Why? Docker is the very required technology from now. It happened to be not so long time ago, but since year 2015 it grows bigger and bigger, and now it's almost always the requirement for a developer or an engineer to know what is it, how it works, be familiar with that, and know how to use that. But DataStax Monday learning, of course, not about only the Docker. So for next 4 weeks, we will meet you every Monday speaking about Docker, how to use that. But also that's about very many different topics. So we are already preparing something special for you. Docker will
Yes.
take almost all of the October. And Cedric, do we have any particular plans to announce for the November?
You know what? Maybe we will run a survey or a slido.com and ask everyone just to vote for what should be the next topic if we can cover it. You know, or a Menti with the 5 top topics we might think of, you know, REST API, or getting started with one language or another. Let's see.
Yeah, definitely. In general, the idea is to make you, our attendees, better developers, stronger as developers, and meanwhile make the IT world, software development world, better in general, because, well, there are some skills missing in the world of IT we would like to cover. So, every week, best instructors, most important topics, from engineers to engineers, no marketing, no proprietary software, but only open source and engineers things. Absolutely free because knowledge and is priceless. So, next thing to cover, Docker containers, these 4 weeks course. We go from very basics to best practices. So if you know what Docker is in high demand, but you don't know what is it, that's exactly the place for you to be today. And that's 4 weeks learning path. It starts today, 28th of September. It will be over on 23rd of October. So 4 full weeks, 4 weeks, 4 classes to learn new things, but also you have your own homework to do, assignment, and that's very important. If you're going to use Docker for real, you have to touch it right now, starting today. And in the end, final assignment. We cover 4 main things. This week and next week are mostly for the Docker fundamentals, so what comes in the basics. We start simple, and when we start to advance. So that's a very good fit for everyone, even a beginner and a software developer in general. Third week will be application development with Docker. Many companies have adopted Docker, but they're using that in a completely wrong way, I tell you. That's very serious. We're trying to use Docker in the way how they developed applications before, and that's wrong. And they obviously do not follow the Docker best practices. So last week will be for Docker best practices, how to do it in the best way, most secure way, more convenient and simple way, plus final assignment. So what we are going to do over these 4 weeks? You are going to learn a new technology, you are going to become a better developer. Every week you go, you attend the live class or watch the recording if live class schedule is not the best fit for you. We run every show, every class we run 2 times. This one is starting right now, and second one will be in few hours for those who live indeed in our time zones, which those are lazy people sleeping right now. Don't take it seriously. So we have the same run, still live, few hours later. Then you answer the quiz questions during the class. Try to be the fastest one because we play and give out some swag. Don't expect anything too big, but there is still some prizes to get. And do the assignment after the class. By the end of the course, do the final assignment, get your achievement unlocked, enjoy, because, well, better developers get better salaries. So that's amazing.
Yep.
Good. And we are at the week 1, Docker fundamentals, and we are about to start. What is Docker? So, best question to answer today. What is Docker? As some of you remember, maybe very many years ago, Sun Microsystems told about Java. The thing what made Java so popular is write once, run anywhere. Basically, on any platform, you can run a Java virtual machine. It means you can run a Java application on that. It's a little bit more complex than that, I guess. I'm not a Java developer, but this idea, write once, run anywhere, is the really great approach, which was basically reproduced many years later by Docker team in the form of build once, run anywhere, everywhere. But now, not only for Java, now for basically every kind of a software application you can write in any language you can use. And that's incredible. In very short, Docker is a set of tools to build, ship or transmit, and run any software packed with all its dependencies at ease. And it really does what it says. It allows you to build, ship and run software on any Docker-enabled machine over the world, and you doesn't have to install any kind of specific dependencies on your own machine. For example, as a developer advocate at DataStax, I work with very different projects. I work with multiple Python projects. I work with Golang. I work with JavaScript. I work with Python again, but in other versions, and so on and so forth. And if I would install all the kinds of dependencies for all the kind of projects I'm working with, my laptop would be seriously exploded after some weeks. And there is no joke, because there are multiple projects, sometimes very complex, and there are those, everyone brings its own dependencies. But what indeed I have on my laptop installed? Only Docker, because everything is packed into the Docker images. If I need a project which brings some Docker images, I just pull them, use them. As long as I don't need them, I dispose them, remove them, and my laptop is simply clean after that, and I don't install anything directly. So, how it works, we will see in a few minutes. Whatever we need to run an application is packed into the image, and when we run the container based on the image, it has all the dependencies within for us to use and dispose when we don't need them anymore. And that really simplified my life. So there are 2 technologies which changed my life completely. Source code version control, namely Git, and Docker. Those are 2 technologies I love the most over years and years and years in the software development. What is Docker? Docker is often confused with virtualization and ideas of virtual machines. Most of you know what the virtual machines and virtualization in general are. So you have the server, you have sometimes host operating system, or if it's a server dedicated for the virtualization, you may have a hypervisor directly on that, and then you have virtual machines running on that. Every virtual machine is the standalone operating system, like all the full system running under the machine with all the required utilities, file systems, I don't know, whatever system processes you may need, and there are a lot of them. So even when you run a small Linux distributive, you still have pretty a lot of running processes, like, I don't know, things like systemd or whatever you may need. And as the things getting bigger, or I don't know if you run Windows, therefore there will be more and more processes to handle. So virtual machines allow you to run guest operating system over hypervisor or host operating system. And that's great. It was a really huge advantage when this approach was invented. It was like a breakthrough. But it also has some downsides. First of all, well, as it provides better isolation, but it also provides some, first of all, they are much more heavyweight. So as you need to have host operating system, you need to have guest operating system, all of those processes are running, and it all, of course, brings a huge overhead. And it's fine in general, because as long as you need strong isolation from one virtual machine to another, and from virtual machine to host machine, but for many of the use cases it was not the best choice. But still, a lot of companies were using virtual machines. For example, at one of my former projects, we used VirtualBox and Vagrant to set up a developer's workplace, and the image of the prepared guest operating system with all the tools required was around 6 gigabytes. So it was pretty long even to pull, besides the fact what it took like 2 minutes to start up. Containers work in a different way. So, idea of the containerization is pretty interesting. Instead of running an operating system inside the operating system and have your processes running inside the guest operating system. So you see, I'm repeating myself. That's because, yes, there is a strong overhead. Containerization allows you to run guest processes directly as the processes of the host operating system in the containers, so they are isolated from the other processes and system processes of the host operating system. Briefly speaking, if you run ps to watch the list of processes launched in the Linux machine, and if you run it with your virtual machine in host system, you will see process of VirtualBox, for example, but you will see no guest processes, no applications running in the virtual machine, because they are strongly isolated. With the containerization, and Docker was originally based on Linux containers, LXC, they were later replaced by their own model. You run guest processes directly as the processes of a host operating system. It brings a lot of benefits. So containers are much more lightweight, and they are much smaller, usually if you do them right, of course, because there are still containers in images like 1 gigabyte or even more. But usually, if you do them right, they are pretty small. And second point, they are much easier to start. So a normal container startup for a simple application which doesn't require some databases connection or overcomplicated things to wait is within some seconds, sometimes even faster. So Docker containers are much more lightweight. They don't bring their own operating system. They don't need hypervisor. Basically, the Docker service process is running alongside them and run them in the memory of the server directly as the processes of a host operating system. They're much easier to manage. By the price, it always comes with the costs of the less isolation from the host operating system and other neighbors. So there are a lot of security layers defending some containers from another containers and defending host operating system processes from containers, but still there is a lesser isolation. Now there is one point. Those containers still have some files, and I say they don't need guest operating system, which is correct, but only partially. They bring their system with them, but it's not running, but the system files they may need to use, and we will see how it works in the practical step of this workshop. So, comparing containerization with virtualization is very simple. Containerization is much more lightweight, provides a bit smaller isolation, but by now in year 2020, this statement is not perfectly correct, because now security in Docker reached some very high level, and I don't know any kind of reports containing containers interacting with another containers or with a host system if you don't explicitly tell them to do so, and therefore define some security settings for them to connect to each other. Good. And very often asked question, is virtualization dead? No. Virtualization is a great technology, it will exist, and it's in high demand, and of course containerization is not the replacement for virtualization, but there are some use cases then containerization is much better because of this lightweight thing. It's always about the thing. There are no silver bullet, but there is a question to get a proper tool for some job you are going to do. Okay. How Docker works? Very simple. Docker is built to build, ship, and run any software. At first, we are going only to build and run to simplify the tasks for the first part of the workshop, and therefore you have only two base concepts to learn. What is the image and what is the container? Idea of that is very simple. We build images and we use them to run the containers. What is an image? Easiest explanation of what the image is that it's a template. So like a class in the object-oriented programming, if you are into object-oriented programming, then you can consider image is an object-oriented class. So you cannot communicate with class directly on runtime, but you can instantiate object of a class, and therefore container will be this object. Image is an immutable read-only template for containers. You can build an image, you can launch a container based on the image, and you can delete an image. You cannot change image per se, you cannot just change the image, but you can build a new image based on the old image. This immutability is a very important concept because it really helps Docker to perform very good in many cases because of the caching and layer transfer and so on, but that's covered in the next workshops. So I will not make a too deep dive, but the thing you have to remember, Docker image is the template and you can run a container based on that. Therefore, what's the container? Container is an instantiated image, a process or a group of processes running in the container in memory of the host operating system. As container is a running entity, you can do more things with that. So you can start container, you can stop container, you can run command directly into the container, you can watch the logs and do many other things you may have to do. Consider container as a dedicated space in the memory of the server or your laptop, whatever you are using. Where you may have one or multiple processes running and you can attach to it and execute some commands there. When I say attach to that, many people start to think of SSH or tools like that. Although it's possible, but usually it's much easier to do with built-in Docker commands, so you don't need to have to run SSH server within the container. I will show you. So as said, if you are into object-oriented programming, container is an object of a class. How to build an image? To build an image, first of all, that's not necessarily to build an image. So you can use an existing image, and in many cases, that's the most common use case. I will show it to you some minutes later. But first, I want you to build an image to understand how it works in general. Most typical way to build an image is to use a Docker file. Docker file is basically just a file in your file system. Call it Docker file. And it has a set of instructions you use to define what has to be in the container when we will launch, which files has to be, what software we may need inside, and so on and so forth. For example, in this particular Docker file on the left, we see a setup, a preparation. We see the Docker file preparing template for the containers, preparing an image to work with Python application, as you could guess. Don't make a too deep dive into that, because we will do it on practice in the real terminal in a few seconds. The main 4 instructions to build an image are these 4: from, copy, run, and cmd. There are much more, I don't know, maybe around 20, I think. But the main 4 instructions are those. When you build an image, you always have to specify from. So, what will be the base image for yours? You always need to have some basement or fundament for your building you are going to build. And in this case, we are building our application from the Python base image, which is a bit advanced step. Again, we will cover later today. Then copy. Copy is an instruction to copy, quite a surprise, files from your machine where you're running Docker build to the final image you are going to use. Run. Run is a command to do some changes in the image being built, to install some software your application is going to use, for example. And then cmd is the finally command your container will execute on startup. Because don't forget, Docker images are not archives by itself, but packet software. And when you work with software, you usually know what it's going to do. So with the command, you specify what exactly it's going to do on the startup. For example, if it's a web application, it will start up some web server, maybe Nginx or something else, and so on. So those are 4 commands we are going to use today. And you know what? Talk is cheap. Show me the code. So let's proceed to the practical part. And we are going to do it right now. And to go with that, I will open my terminal. I will make it a bit bigger, so you will see that, hopefully. Hello world. Is the size fine? Can you see what I'm typing?
It's small. It's a bit small to me.
Okay, I will make it a bit bigger. Good. I hope now it will be fine. Good. And we will start with something very simple. I want to create a folder. I will call it Docker test. And I will switch to this folder. And let's build an image. We are going to create our first Docker hello world. Isn't that exciting? So first thing I'm going to do is to create the Docker file. Again, Docker file is just a file in your operating system. So I call it Docker file, and I'm going to add some instructions into this file. And again, first instruction, what's the most essential instruction for me, is from. From specifies the base image I'm going to use. And now I'm going to use any default Linux image. I don't know, let's say Debian. Or maybe, yeah, Debian should be fine. Debian. And I can even keep it like that, and I will have my own image, which basically will copy default Debian image. But well, it's pretty boring. And as said, I'm going to have it as a hello world. So I will say cmd. Cmd statement specifies which command will execute my container on startup, and it will be a simple echo hello world. Simple as that.
We had a question for you, Alex.
Yeah.
What is the difference between CMD or run in a Docker file?
Good question. I will explain run in a few minutes.
Okay.
Yep. So stay tuned, stay with us. In general, very briefly, difference. Command, when I run docker build, this command will not be executed. That's the specification for a container to execute it when I will run a container based on this image. And when I type run, this command will be executed directly on build time, not on runtime.
Okay.
So that's the main difference. Run is to set up an image, and command is to be executed on the container. It will be clear. Don't be in a hurry. It will be clear in some minutes. Good. So we have from Debian command echo hello world. And I'm going to save this file. And as I have this file now, very simple and small file, just a hello world, as hello world should be. Now I'm going to build that. To build that, I'm typing docker build, and when I specify what exactly I'm going to build. In this case, I want to build a Docker file located in this folder, in the current folder, Docker test. So I simply set dot to say it's a typical Linux abbreviation for to say this folder. Sorry. And I run that. Oh my God, of course. Actually, I'm a Linux guy and I'm used to work with Linux, and
oh, you need to start Docker.
I have to for my MacBook. I have to start Docker. I just rebooted my laptop, getting ready for this workshop. Sorry, so it will take on MacBook to start Docker. It will take around, I don't know, 40 seconds or something like that. I'm using Docker for Mac. So while it's starting, 2 words to explain. Docker is based on was based on the Linux container, and that's still basically a Linux system. So on Linux it runs natively, no questions. But if you have OS X on MacBook like me, or if you have a Windows machine, it's not so easy, because Linux processes cannot run natively in Windows or OS X. Very clear. So to do the exercises from today's class, you will have to install Docker for Linux if you use Linux, Docker for Mac if you use Mac, and get back. Yeah, good. Docker desktop is running, and Docker for Windows if you have Windows. If you have Windows 10 Home Edition, you may be in a little trouble, because there are pretty hard thing to install Docker or Windows 10 Home, but we prepare it. We found a great tool for you to play with Docker without installing that, to be explained in the end of the workshop. Okay, very well. So let's move on. I'm going to docker build docker build in the current folder. Oh my God. And there are some things happening. First of all, sending build context to Docker daemon. Docker is the client-server system. So there is a Docker daemon running within my virtual machine with Docker desktop. And Docker client, which is a console command line client, which executes my commands. In this case, Docker client sent everything I asked it to build to Docker daemon, transfer it to its server. First step 1 of 2, from Debian. Okay, so I specified Debian as my base image. Okay, latest, I will explain it in a moment. Pulling from library Debian. I don't have this image, Debian Docker image, on my laptop, so it was downloaded. Pull complete, it was downloaded, and that's its ID, pretty long one. Downloaded new image for Debian latest, and step 202, command echo hello world. And finally, successfully built, and that's the ID of the image I just built. Let's take a look at the Docker images. Docker is my command to ask Docker to do something, and images is the list of images I have. And wow, I have pretty a lot of images here. When I ask Docker to show the list of the images I have, it usually shows me multiple things. First, repository, so the name of the image, for example on the left side, tag, I explain soon, image ID, when it was created, and the size of them. So as you see, I just built a new image, nameless, it has only an ID, and I'm going to copy paste this ID and say Docker images grep, put my ID. And that's my image, which was built a minute ago, and it has weight of 114 megabytes. So, okay, now I have an image, but image is not something I can communicate directly. I can build one, I can delete one, I can watch the list, but now I want to run a container based on this image. And you may try to guess how my command will look like. And command will be docker run, which says to Docker to run a container, and then I therefore have to specify the image I'm going to use, and that will be my image. And I have to scroll it a little bit higher, so you will see the output. And the output is hello world. Congratulations, we just executed a first very simple hello world we did for them. We did in the world, and you are going to do so again as a part of your assignment later. So that's great, but as it's a hello world, it's not really useful. So let us take a look if we can do something better. To do so, well, usually Docker works with long-running containers. Well, not long, but sometime running containers. In our case, our container just said Docker, just said hello world, and immediately exited. How to check that? I will say Docker PS.
Yep. Okay. Just for everyone to see, you should put the prompt just above you because you're in front of the prompt, or you can hide yourself on screen.
Yep, you are right. Give me a second.
Or come close to me.
Yeah, you are right. Let me move closer to you. Thank you.
Are you hiding the prompt? Yep.
Yep. Now it will be better. Now we are shoulder to shoulder, Cedric.
Oh, good. Nice. Okay. Put your mask on.
Yeah. Well, there are still 4 hours by car from my place to your place, so I hope we are safe enough. Good.
Yeah, I can still disappear,
Get back, get back. Good. So, to watch the list of Docker processes, I can run command docker ps. And it's empty, because my container just quit. It's as long as the main process of the container is running, container will be running. As long as the main process, first process, process PID0, so call it in Linux, quits, container will be also quitted. So how about to run something longer running? I will run thing. Let me switch to another folder. very well, and we have nope. Yes, exactly. I will run this file. So let's take a look at the next file I'm going to run. And next image I'm going to build. First one, from. This one should look pretty familiar to you because, well, from says which base image I'm going to use. By the way, I've seen a good question in the chat, what's your favorite base Docker image? Asked by Gerard Goulain. In general, answer is very, very cheap. There are no favorite base image. It very depends on the tasks you are going to do. But in general, I try to use Alpine as much as possible because Alpine is the minimum minimorum, the smallest distribution you can use for Docker. Well, not the most smallest, but the reasonable smallest one you can use to build as small images as possible. We will speak about Alpine at the workshop best practices. Good. So, this one I'm going from Ubuntu. Why? Just because I can. Then, second base command, I mentioned it some minutes ago, run. Run is the command to be executed during the build of the image. So, in the first step, I'm going to reuse Ubuntu. And the second step, I'm doing apt-get update, and I install Nginx web server, mostly probably you know. And in the next command, this one is important one. This one is to be covered better at the second week, but very briefly. When yeah,
we got the question, what is Nginx used for?
Nginx?
This is a web server.
That's yeah. Stop, Cedric. We have people of very different experience, so
No,
don't
but
laugh.
No, it's just because you said, oh, you probably already know. Boom, you got the question.
Okay,
yeah,
so
that's super fun.
My bad.
Question, by the way.
Nginx is a web server, so is a software which answers web requests, mostly probably when you are open website in the internet. There is some software behind that, and I believe Nginx stands behind at least half of the websites in the internet. So it's one of the most popular web servers overall. Then second thing, this one may look like a little bit tricky right now. So let me simplify that a bit. Those two commands are needed to put logs instead of the normal log files into def-stdout and def-stdir. That's a little bit, that's a lot actually, not a little bit about Linux things. I don't want to make a too deep dive into that, but in very short explanation, I run those two commands to have Nginx logs as a normal Docker logs output, because Docker treats everything what goes to def-stdout and def-stdir as its own logs. And the most important and the most proper way to handle logs of your application, or Nginx in this case, is to put the logs into stdout for access log and put error log into the stdir log. If you are familiar with Linux, you understand what I'm saying right now. And ln is just create a soft link to put the things to a proper channel. Then finally, I don't need that right now. And final command I need, that's the command which will be executed on the container startup. So first, nginx -g daemon off. What's going on here? So nginx is the command to run nginx. That should be pretty clear. But what happens in these two and the second and third arguments? Very easy to explain. Do you remember what I told you in the beginning? Then core process P0, or the main process of the container quits, container quits as well. And the case is, there are two kinds of execution in the Linux system, foreground or background. So the process will be executed directly, or process will switch to background and execute it in the background. I'm simplifying, but that's the main idea. Basically, you see the process running right now, or it's somehow hidden in the background. And Nginx by default starts in the background. But for the Docker, it looks like core process quits, and therefore, if I do not put these two arguments, Docker will consider Nginx as just exited, and it will exit and kill the container as well. To avoid that, I explained to Nginx it should not go background, but it should switch daemon off. It should work in foreground, so Docker will understand my Nginx is running. Okay, so I'm saving this file, and I'm saying a familiar command for you. Docker build what? Which sign I should put right now? Dot. Because I'm building in this current folder, exactly. And process is happening, and process is done. You may ask, you have downloaded Debian before as a part of a build process, but this time you didn't download Ubuntu. How come? Answer is very simple. I have Ubuntu on my laptop downloaded already. The Docker image or default Docker image for Ubuntu. Then apt-get update and apt-get install -y nginx. So why was it half second, quarter second? Why was it so fast? Very simple, because I execute this build in this folder already, and Docker uses caching very heavily. As soon as it sees what nothing has changed, it will, as said here, using cache. And that's very important, because sometimes build of a Docker image may take literally hours in some use cases. So you do want Docker to use cache when possible. When we do these two simple run commands just to create links between access log and defasted out, error log to defasted error, and then finally I set up this command for a container to run. Again, command statement is not executed on build. It's just the setting for the container, what container will do.
Yeah. Alex, exactly on the command line. So every single argument is put under double quote. Is this the way the command work? You know, all the parameters should be double quote.
Not necessarily, but this approach is the, how to say, considered to be most clean and conscious, and that's the way how in general you have to do it. So you've seen before I just wrote cmd echo hello world. Will it work? Yes, it will work as well. But in general, that's not the best practice. Best practice is to write it like that. So basically, I type the statement command, and I'm giving some arguments in an array.
Okay.
Good. So now I have this successfully built AB38 blah 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 blah, which is very good. So my build process is done. And now I can do first Docker run AB38. There is a nice Docker hint. You may not type the full Docker ID because, well, full Docker ID is much longer. So this then is an alias, but you may even not fully type the alias. You may start to type the first characters, and as soon as it allows to uniquely identify an image or a container image in this case, it will execute these. It will find the most proper image. And I say Docker run. And nothing happens, but Nginx is running. But here comes a little problem. If I open my browser and I go to localhost, I will have nothing. This site can't be reached. Why? Answer is very simple. Security. By default, Docker will not publish ports of the running container to the host system. And I have Nginx running, but there is no way to reach it by itself in this way. So I want to use a first argument to Docker run command, which you are going to use a lot. It's called publish. And then I specify 80. So that's important to remember. On the right side, I specify the port of the container. Right side is always for the container. If we speak of ports or volumes, we will speak next week. And the left side is always for host. So left side is my computer, is my laptop. And right side is the container I'm having to run. So, and if you want to specify that, you can simply type docker run -p. It just will be shorter, but today I will try to stick to the official arguments options. And I say docker run publish host port 80, container port 80 publish, and I give the ID of the image. And again, nothing happens. But okay, that happens already. Yes, because my browser remembered what I was trying to reach with host. And as you see, Nginx is running. And here we go, and I have my logs here directly. Okay, so now we have Nginx running. But the problem is, as soon as I will close this terminal, Docker container will quit as well, because I run it in the foreground, and that's not the best way to run things. So I want to stop it. Localhost is not available anymore. Pretty obviously, Nginx is stopped. And now I want to add one more option for you to remember. In simple, it's -d, or full name is detached. Oh, detach, sorry. Perfect. What happened now? I have some long number and nothing more. Hey, where is my Nginx? Is it there? Yes, it's there. But where are my logs? Very simple. Do you remember the command I used to watch for the containers running? It was docker ps. And my screen is a little bit too big. I will make it a little bit smaller. Almost done. Yes, and I will scroll it up so you will see it as well. And let's see docker ps. We have a container ID. This part is very similar to this part, as you could see. Very simply, when you run a container in detached mode, when you run a container in background, Docker will print ID of this container for you to use if you need this ID. And here in the docker ps, it prints the alias, the short form of a unique identifier for the container. When it specifies the image, base image, we use it to run the container. Specifies the command, we use it to run. So nginx -g daemon off. You remember that as a cmd statement in Docker file. When it was created, what's its status, any forwarded ports, and what's its names. Docker has a pretty convenient idea or concept. When you work with multiple developers and you have to discuss different running containers, it would be not convenient to say, hey Cedric, how it goes with YCB06D2F65E7, blah, 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 blah. No, that's not convenient.
Can you spell it again?
Yeah, exactly. So to improve that, they give some random names to containers. And if I will run a container based on this image again, so I will have another container with another name. But think a little bit. What will happen if I will run this command again? That's the tricky question for those who understand ports. If I will run this command again, I will have an error from daemon. Driver failed because port is already allocated. The trick is I'm trying to allocate host port 80 container port 80, and container port 80 is free because it's a new container, but host port 80 is already busy, of course. So now I'm going to run this container again, run this image again, create a container, but I will link it to another port. And again, I have a long ID. Now, if I do docker ps, I will have a list of 2 containers running, and those are 2 different containers based on exactly the same class or image class in the terms of object-oriented programming. And they have different ID, they have different runtime, but the general idea is exactly the same. There is an Nginx running, and I can now open Nginx on my port 80, and I can open Nginx on port 81, and they both are available, but those are 2 different ports and 2 different containers running. And as we are speaking about the containers and what we can do with them, second important thing you will use all the time is you will want to see the logs. To watch the logs, there is a highly secret hidden command called docker logs, and in the end you specify the ID of container. It makes no sense to specify the ID of an image, because image is not a running entity, but the template. So you have to specify the ID of the container, and I can simply type 96f. It will be enough, hopefully. Okay, and I see the logs here, and I see what this container, which is up for some seconds, has only 2 requests. But if I ask for logs of container ESCB06, I will have much more logs because I've executed multiple things. And now, mostly probably in the debug purposes or development purposes, you are going to use logs a lot. So there are 2 more secrets you are going to need to be successful with docker logs command. First one option is called follow, or briefly speaking, F. -F. -F says follow. So I will not detach from logs in the end of the logs. And if I will renew this page multiple times, I will have no more logs because it's the second container and I'm watching logs of the first container. So I'm going to open at port 80, open multiple times, and boom, I have more logs coming in. Very well, very good. And next point. It's next thing we want to do with a container, mostly probably at some point we want to stop it. Don't forget, those containers are still taking your memory. So we want to disable them. By the way, if you take a look at the settings of Docker, desktop Docker for Mac at my place, and you see my preferences. Can I have my preferences, please? Yes. And you watch the resources, you have some very solid numbers allocated. Of course, Nginx doesn't require so much, but usually no one runs a single container, just a single container. Actually, by one very nice research in year 2017, most of the people using Docker reported what the medium amount of containers running per project is around 8 containers per host system. So therefore, to run some complex systems, you definitely may need some more resources. So if you are going to launch multiple containers, heavy containers at once, don't forget to allocate more resources. Otherwise, you may run into some serious problems with your containers running. Okay. So, by the way, there is some graphical user interface at desktop for Docker, but that's not true. I prefer to stick to old school command line. You can learn user interface on your own in the very end. Okay, so again, I want to stop my containers. And there are 2 main ways to stop the container. First one is the gentle one, docker stop, and you give the name of you give the ID of the container. In this case, it's a graceful stop. So first, Docker sends a sigterm signal to terminate Linux definition to a container like, okay, your time is over, you are going to quit. And container has to process these signals. In our case, Nginx receives this signal, Nginx knows what to do with that, Nginx quits. But there is a second, much more brutal way to stop the container. Call it docker kill. In this case, Docker will not send a sigterm, but immediately sigkill the running container. That's a much faster way. And in this case, we had like half a second of difference. But when you speak about big systems running on your own laptop, in some case, you want to save some time. And if you speak about the production system, mostly probably you are going to use docker stop. Because, well, this container may have some time to store data, to persist data, or finish processing requests. Okay. And the last change I want to do. We have this Docker file here. And I want to put a little change into that. And I want to discover the last main statement you are going to use in your Docker files. Copy. Copy is the command to copy a file from your laptop to the image on the build time. Notice I highlight the build time. What does that mean? Answer is very simple. You build once, run everywhere. At the build time, you copy this file to the image. It will be stored within the image, and then you can send this image to your friend, to your colleague, store it to a registry, and we speak about anyway distribute that, ship that. Build, ship, run. And that's a very important point. Do not copy any kind of credentials, any kind of security things, passwords, tokens into the image. Don't put essential information or secret information like that, because after all, you do not know what will happen with your image. You will send it to a private image, when you will give access to your colleague will pull this image, your colleague will push this image to another registry, which is not secured anymore. As soon as you give away image with everything what's within the image, you may say goodbye to that. There is a very low amount of ways to try to secure it anyhow. So watch what you are putting into the image really seriously. In my case, I'm going to copy file index.html located in this particular folder. I'm building the image, and I'm putting it into var www.html index nginx debian html. So I told you, please don't forget, left side for the host, right side for the container. In this case, I'm copying from left to right. I'm copying from host file index.html from current folder, and I will put it to var www.html index nginx debian html file. I uncommented this line. I store the file. And what I have to do now, think for a second, I changed the Docker file. I want to have a new container. I have to build a new image, because image is an immutable. You can create an image, you run a container out of image. You can delete the image, but you cannot just change the image and store it under the same ID. Well, there are other ways, but don't do that.
Please.
Yeah, seriously, that's one of the worst anti-patterns you may have. So I'm going to do docker build dot, so docker build in the current directory. And boom, it's executed very quickly. Why? Because for every of the statements, instructions, before the one I've changed, before the one I've added, it used cache. Using cache all the time, because only step 5 was added, and therefore all the cache on the step 5 and later was discarded. But before step 5, all the cache was used. And we copy this file, and we have this one, and we have successfully built a new image. And we can find it with the command docker images. And to make the list shorter, I will make grep and say bd7b. Boom! That's my image. It has no name, but it's very fine because it has an ID. And now I can say docker run publish port. I will need to publish port 80 and detach. But well, actually, I don't have to detach because I will be fine running it at foreground. And I'm specifying bd7b. Execute. So no output. So far so good. Let's open my localhost. Boom! And we have hello world. Now you maybe can guess what's located in the file I've just added. So file index.html. I'm going to show you this file, but by now you have to understand what's that. Hello world, very simple. By this copy command executed here, I've replaced default index nginx debian file with my own index.html file. And I can put whatever I want into this file, rebuild an image, and I will have this image built here and available. Good. So, not so much time left. Let's move on. Good. So, things we covered. We covered a Docker file from copy run cmd. We covered Docker build with no name. We will cover Docker build with tag in the second demo. We watched our Docker images, and you've seen what I have plenty, a lot of them. We did Docker run. We did default Docker run in foreground. We did Docker run with publishing ports. And we did Docker run in detached mode, so Docker container will be running even when I quit the terminal. We did Docker PS to run to watch the list of the containers running. We did Docker stop and Docker kill to gracefully stop or forcefully terminate running container. And we also we didn't do Docker ERM and Docker image ERM, but we will do it as a part of the next demo. When we just have seen how to build a simple Docker image, and we just seen how to run a simple container based on this image. But Docker says build, ship, run. What about ship? How you are going to use our images and how others are going to use your images? Let's take a look. To transfer images, we need to know how to push and pull images. And to transfer images, we literally use commands docker push if you want to push your image and docker pull if you want to pull the image. But where to push and from where to pull, answer is registry or repository. There are multiple available Docker repositories in the world. The most famous one, like the most widely used, is the hubdocker.com. We will see it in a moment. And you are going to use it today or later this week, depends on your free time. And hubdocker.com is the main one. In general, Docker registry or Docker repository is the thing what stores images for you. And when I say Docker file from something, or when I say Docker run something, what happens? We need a base image from where something. And by default, it will use hub.docker.com. Let me even switch for a second. So I go for hubdocker.com. And that's the main official repository for images. If you want to pull publicly available images, then you don't need to have an account. But I highly recommend you to create your own account. Actually, that's the part of the assignment for today, for you to be able to push your own images to the Docker Hub. As long as your images are publicly available, kind of open source, it's completely free. You have to pay for Docker Hub only if you have multiple repositories, multiple images are private. So only logged in person who you gave access may download your images. For open public images, it's completely free. And you may have thousands of different absolutely official images here we are using. You have Postgre, you have Oracle, you have, I don't know, of course, you have Cassandra, and of course you have DataStax images here.
Can you try to zoom in? Yeah, can you try to zoom in? It's
yes, thank you. Sorry, I forgot to zoom. Usually I never forget, but here, yes.
Yeah, thank you.
Yeah, so we have some Cassandra things, we have DataStax Enterprise, of course, and many others. For example, you remember we just run an Nginx, and to run Nginx, we use it in Ubuntu, and we did apt-get update, apt-get install Nginx, we gave a command. But you know what? Good developer is a lazy developer. Why should we install Nginx if Nginx team did it already for us? You have official build of Nginx available right here with more than 1 billion downloads and very many different options for all the cases you may want to have. And that's perfectly works. Good. But that's the part of the second demo. And you will use Hub, hopefully today. And well, that's live demo second part. So we are going to do some things very quickly in the terminal again. So I just said we did this apt-get Ubuntu, apt-get update, install Nginx. Stay lazy, stay efficient. Why should I install Nginx if I can say docker run Nginx? Unable to find image Nginx latest locally because I don't have it locally. What happens then? Docker goes to hub.docker.com and pulls default Nginx image.
True.
Yep. And image consists of multiple layers. We will cover this topic more in the future. And I should have used Alpine, but that doesn't matter. It's stuck for first layer, don't know why.
Yeah, it's downloading. The question about Docker Swarm, I would say it's not used at all anymore, right?
Oh, yeah. I see. Debarun Pal asks, shall we learn Docker Swarm? Is it used these days? So, with all my respect to Docker team, Swarm is not in high demand and not in high use anymore. It had chances, but it was in the direct competition with Kubernetes, and Kubernetes has won. So now everyone who has to orchestrate containers on multiple machines, multiple containers are using Kubernetes. And Swarm, for example, Swarm is installed by default in Docker for Mac, and I'm using Docker for more than 5 years. I used Swarm 2 times in my life to estimate that. And in the end, we in my former project, we stick to Kubernetes as well. It doesn't mean Swarm is not in use. But yes, there are some better, let's say, alternatives from my point of view. Good. So we see what Nginx was downloaded and started with a simple command docker run Nginx. And well, I don't have my port open, sorry, so I have to publish 8080. Good. And I can go to port, come on. Of course. I can go to my local host And oh, okay. Okay, welcome to Nginx. That was cache. That looks better. So Nginx is running and receiving my requests. But now, one very important thing. You maybe have noticed it. What I didn't do Docker pull command. I did Docker run command. What's the case? How it happened? Very easy. When I say Docker run, Docker will execute pull for me automatically, so I don't have to explicitly say pull. But if I want to just download image without building anything, just to have it on my list, I may say docker pull hello world, and hello world image will be downloaded. It's a default tiny Docker image, and it will be downloaded without running it, creating containers or anything. Boom, we have downloaded this image. And there is the next thing, call it Docker push. I use it when I'm going to push my own images, and from now on we cannot use just IDs. So as you remember, we were using these IDs, long IDs, blah blah blah, BD, 7B, and so on. That's fine when you're working locally, but when you work globally with hubdocker.com, you may want to have more conscious names. So, first thing I have to do when I'm creating a new image, I want to create my own repository for that. So I have my repositories here. I will create a new one as my account. I will create a repository and I will call it hello world. Okay, it will be public, so you can use it. And I will create that. Boom. Now I have repository Hades Architect hello world. Now, what I'm going to do now, I need to link my image, existing image or new image, with this repository. First way to do it, when I build an image, I may say -t or -- tag. I will use the short one, -t, and I have to give it the name. So first one will be a name of my profile, Hades Architect, and second will be hello world. That's the repository I'm using to store this image. And last point, I have to set the point. I'm going to build it locally. It's going to be quick because it was built recently, so I'm using cache. But now, you remember, like build, use it before, successfully built, BD7B, blah, 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 blah. Now it has the name, successfully tagged, Hades Architect, so owner, hello world, repository. And the final thing is tag. I will explain in a moment. And now I can say docker push, and I give this name of the image I have. It will be Hades Architect / hello world. So owner, repo, tag, and I'm pushing that. And it pushes the image. My channel is pretty busy with the stream, so it may take a second. But in general, that's the thing you have to do when you are pushing the image. And in a moment, that's a very nice optimization I really like. Take a look. You remember we built from Ubuntu. Image consists of layers. And those 4 layers were built and pushed. But those 3 layers were not uploaded at all because layers of exactly this content were already stored at the hub.docker.com, and therefore there is no need to upload them because they exist already, and it mounts those images from library Ubuntu, and that's really cool. In this case it was pretty quick, but when you work with huge images, which still happens, we will teach you not to do that with our best practices class. Those 3 layers were simply mounted and never uploaded, never transferred via internet, which is great. And my image is downloaded here. Okay, and I can renew my page. And I should have my repositories. Yes, Hades Architect, hello world.
Great.
And we have, with this repository contains 1 tag, which is latest. Okay, so what's the tag? Let me explain you. Let's go for Python. I see a lot of you are using Python, and that's very easy to explain what's the Python, what's the tags are based on the Python. The trick is, everyone who works with Python knows very well, there is no a single simple thing like Python. But you have Python 2, Python 3, 3.8, 3.2, none of them are compatible to each other. Some libraries are using some specific versions of Python, and so on and so forth. So, tags we are using to build different images for the same repository. For example, if we see list of tags for Python, we have latest, which is latest available Python, but we also have Windows Server Core, Python for Windows. We also have Slim, which is again default latest Python, but the image is going to be smaller because, for example, default Python latest, see, the size of the Linux version is 330 megabytes, but the Slim version, which is designed to be smaller, is only 40 megabytes. It means what some dependencies aren't installed and some external libraries may be not available. Also, they're usually available in Alpine version. Alpine is a very tiny Linux, so 3.12 Python on Alpine is going to be 16 megabytes, which is much smaller, therefore, and easier to work. Oh, sorry, it's not 3.12 Python, but 3.12 Alpine version. And so on and so forth. You have 3.8 Python. You definitely will have somewhere down Python version 2. So as you see, there are really a lot of different versions, different tags for the same repository. How do I use that? Very simple way. I just built my hello world, but I want to change something. I go to my index.html file. I'm saying hello everyone from Alex. Control X, yes, I'm going to build this image and I will set a tag on that. I will say Alex. And otherwise it looks exactly the same. Build process happens very quickly. Till level 5 we are still using cache because this is a cached things. At the step 5 cache is invalidated because some files are changed. And therefore at this step we stop to use cache and start to build from scratch. So no cache anymore, as file has changed and I have new one. And you see successfully tagged Hades Architect, hello world Alex. And now I can say docker push instead of latest Alex. And now it should happen much quicker because of the same layer already exists thing. So basically only one layer was changed and I'm pushed only one layer and all others will reuse it because all the apt-get install Nginx are executed already and stored at hub.docker.com. That's damn amazing. Okay, and we have a new tag, so I can switch to my own repositories. I can open my hello world, and in the list of tags, I will have my 2 tags, latest and Alex. And now there is a thing. You may ask me, but Alex, when you did a build for not the Alex version, but for the latest version, you didn't specify latest here. But you push it for latest one. What's the trick? What are you hiding? My answer is I'm hiding nothing, at least not from you. By default, this one is absolutely equivalent to this one. So if you set no tag, it will be tagged as latest. And if you say latest, it will use the last, this one default without, so latest is the same as completely without any tag. Latest is the tag by default. One last trick. In my case, I am logged into Docker Hub in my console. That's why I can push. But for you, one more command you will need is docker login. And you will have to give your password and username. In my case, I don't have to do that because I'm logged in this terminal already. Anything else to show? I've shown all of this. And final things. Speaking about the cleanup. I have to delete some things I don't need anymore. So, to delete an image, I give docker image rem. I am going to delete hello world. And notice I said no tag. What does that mean? It will use tag latest, default tag. Boom, untag it, delete it. And if I want to delete the containers, take a look. I have no containers, but that's not the full truth, because I can say docker ps -a. And I have a lot of them. Oh my god, I have to do a serious cleanup. So as you see, I have a bunch of containers existing from 5 months ago, but not executed anytime. And to remove a container, I'm going to go for docker rem and give ID of the container. Boom. And I have one container less. I promise to you, I will do a big cleanup today. That looks like not how it should be. So, demo 2 is over and we are very close to a final slide. How about real application? Because now we did very simple things and how it works for the real applications. Okay, that's a very simple example I have for you. That should be in my Flask. Okay. We are a little bit out of time, but we are mostly done. So just a couple of slides left. That's a very simple folder which imitates a very simple application using Python and Flask framework. Let's take a look on what we have here. I see a lot of people have experience with Python. If you don't, I will explain you. File requirements.txt is the file by default you use to define dependencies of your project. In my case, file requirements.txt consists of only one line, Flask version 1.1.2. What does that mean? My application is going to use Flask framework. Then appy is the application by itself. Let me show it to you. That's a very tiny Flask application. We import Flask framework, we create a Flask application, and we define a root or method to call, which will be executed when we open the main page of the application, which will just return hello world. I will even change it a little bit to be hello world, hello from Docker. We did hello world already today. Hello from Docker. Very well. And final file, so we have only 3 files, is Docker file, as the Docker file we need to build the image. Docker file looks like that. Okay. I will better use nanam. Good. So, from Python 3 Alpine. And now you know what's going on here. From is the base image we are going to use. And we will not use Ubuntu or Alpine, but we will go directly to the Python, official Python image built by Python team, which is prepared maybe much better than I could do that, because, well, they are professionals working explicitly with Python. And now we know double point, it separates tag from the image name, so we go Python, and the tag will be free Alpine. So this one specifies it will be Python version 3.8, so 3 latest, but it also will be based on Alpine Linux to make it smaller. Second instruction, we didn't cover it before, work dir you can guess workdir sets the working directory in the image for all the next actions. Copy. Copy is to copy. Very simple. First dot. Don't forget left side for host, right side for image or for container for Docker. I'm going to copy the current folder. So the folder we are in, Docker file, appy, and requirements.txt to current directory in the image. And what's the current directory in the image? See one line above, usr src up. Next instruction is familiar to you, run. What we are going to do? We are going to run pip, Python manager for dependencies. We're asking that to install. We're asking that to install from file requirements.txt. And this is not really required here. I will explain it in the next workshop, or better in the best practices. So we can clear it up right now. We don't need that. Env, that's the next and last for today in instruction for the Docker file. Env means environment variable. In this case, we specify two environment variable. What would be a default file for Flask to run? Flask up will be file up.py. And Flask environment will be set to development. That means what Flask will run in development mode with debug enabled. And finally, CMD should be familiar for you as well. We are giving command to run Flask with some options. We call Flask to execute run, giving options. Host will be 0000, open, and port will be 80. And that's all what we need. Now I'm going to build that. So who remembers how to build an image? Docker build dot. I build that. Now real build happens. Now it's very close to a real Dockerized application. It's very simple, but that's for real. First, we are using Python 3 Alpine. It's downloaded already. We set the workdir. We copy all files. We run pip install requirements.txt. Here comes the pip install by itself. If you work with Python, you may recognize those lines. We are collecting Flask, Werkzeug, Jinja, and so on, and installing those dependencies here. Then we set up environment variables. We are going to need Flask up and Flask env development. We run and we set the command for the container. What's going on to happen right now is very simple. I have to run this command, docker run fdb1. I will need to specify the ports to publish. It will be again 80, 80, left for the host, right for the container. And I'm running this one. Woo! It works. We see what Flask application is running. We see what environment as a development, and as we specified here. It runs on 000 port 80, so it's available for us, and debugger is active because of environment development. And we can go to our port 80 localhost and open it and see hello from Docker. That's the real Python application, very small, very simple, but it's a Python application using framework Flask. And
Great.
Yeah, indeed. And final thing for us for today, we want to do. As we are speaking here, and you see logs, my request has come. And final thing we want to do for today is very simple. You have noticed what I'm specifying environment variable Flask env development. And those of you who relate to ops or DevOps may be unhappy. What does that mean? This image will always be running in the development application. How the hell I'm going to run it in the production with a debugger enabled, with, I don't know, stack trace put into the browser, so every client will see our stack trace, or maybe even credentials? Go on, let's play, let's put the passwords here. No. One of the easiest and best ways to set up application, set up Dockerized application to run, to behave differently depending on the environment you run. development, staging, production, or to set up different passwords, because your password and your colleague password may be different, are the environment variables. When I set the default values in the Docker file, I specify just env, flask up, flask env, whatever environment variable you may need. But I also can change that. Take a look. Here I was running this container specifying only the port to forward, port to publish. But I want to do one more thing. I'm doing -e, which stands for -- environment, -env. And I'm setting that flask env equals production. Who knows what will happen next after I run that? If I did no mistake, Flask says environment production. It warns me. Flask is a development server, don't use it in production, because I told them we are kind of running on production. Use a production VSGI server instead, well, doesn't matter. Debug mode off, we are running in production. This way, I define a default image I'm storing and I'm working with, but when you run the same image, change its runtime behavior, but just giving new value here, -e flask env production. And it still will work the same for the end user, but we know what there is no stack trace published to browser, and there is no debug mode enabled. And that's incredible. So, a little bit of homework. We have only 5 things to do, but I will start with the bottom one. If you have any friends or colleagues, if you watch this video live, or well, if you watch this video not live, but anyway, it means you liked that because it's the very end and we are pretty a lot over time. So I'm happy to have you here and thank you for being with us. Invite a friend or a colleague. That's the first week and it's a perfect time to jump in. As you see, there is no marketing bullshit or anything like that. There is engineers to engineers about engineering things. So invite your friends and colleagues. We will be very happy to see more people. To join the participation, we have to register at the Eventbrite page where you have mostly probably registered. And now regarding the real things. First, you will have to create an account and hubdocker.com. Second, which may be a little bit harder, you have to install Docker or make yourself familiar with labs.playwithdocker.com. Simply speaking, where is my browser? Oh my god. Okay, yes. Labsplaywithdocker.com, given you have the ID or Docker ID, is the web-based Docker terminal. You can work with Docker directly. It's not the most convenient way to use the Docker, but it's the easiest way to use the Docker if you cannot install that. I'm logged in using my hub.docker.com ID. I'm adding a new instance. It's completely free. And now I have my application running right here. So I can say docker run nginx. Of course, I have to pass through the ports. Publish 80, boom. It pulls nginx. It runs nginx. Here you have button. You will have button in a minute. Open port 80. Yeah, it's just appeared, and you can click that, and you have your application running and available. So Docker Playground is a good thing. You may have some instances. You may play with Swarm if you want. Well, we don't explain Swarm this time. It's the easiest way, but not the most convenient. I recommend you to install Docker locally. Then the main step, containerize a simple Hello World application in the language or framework of your choice. Please choose a simple scenario, like the Python Flask application we did today with Hello World. Choose something simple. simple. Don't take a complex multi-container setup with caching service, databases, and so on. Pick something simple. We will advance next week, and you will do much more complex job next week. Ensure you use it every command from today's class for the Docker file and command line. And push your image to the Docker Hub, to your new very own repository. We will need them next week. Thank you so much, and see you next week.
Yeah, it was great. What a good hands-on.
Yeah. Now, Cedric, I have a question actually for you.
Sure.
Our attendees may need a way to communicate with us during this course, and I'm thinking what the best way would be maybe to use a dedicated channel at our Discord server. What do you think?
Totally agree.
Okay, very well. So let me show you then our Discord server you will use to ask the questions. Easiest way to go to our Discord server is to type bit.ly/Cassandra workshop. I will send this link soon to you. So actually that opens Discord. I have Discord as an application, but you may use Discord in the browser as well. I don't want to open an app. I want to open Discord in the browser. And we have our own server here running, and we are to create a special channel for Docker related things. And I will wait for you there and answer your questions. Cedric, thank you so much.
Oh, you did all the work today. I'm just listening and learning.
Well, that's my own course designed out of years with Docker. So now I can't wait for your Docker Data Stacks Monday learning coming next month. It will be great. I'm absolutely sure. And
count on that.
Thank you so much.
See you soon. See you next week.
See you next week.